all of this stuff recorded. Okay, probably have it recorded once before, but I'm gonna have it recorded again. So what I want to point out is, when I grade homework assignments, I'll be looking for certain things. In the past homework assignments, if I mention the format is wrong, or it is blank, it doesn't have a name, or the revision history is not there, I'm going to go back and revisit all of those and give points back, based on the content. Okay, but from now on, I'm going to make sure that I enforce those particular rules, and I'll go over what I mean by those rules. Okay, so here we go. All right. So when we do homework assignments, this is typically what we'll see in a homework assignment. So we'll go for more nested here. Okay, so what I want to emphasize first is how to get started with a homework assignment. Now, I know I'm preaching to the choir. 75, 80, 85% of the class already know the drill, the routine, and did it right the first time. But I just want to make sure that everybody understands what I'm expecting when I'm grading homework assignments. So you do a right click and you save the file to a certain location. So let's say I save it to the temp folder. You probably save it into a download folder or whatever. It doesn't matter where you download it. Okay. Next, you want to use LibreOffice or OpenOffice to open the document. So in here, since I'm using Google Chrome and I do have LibreOffice already installed on this computer, I just go ahead and open it. Now, before you do this step here, you have to make sure that the account that you're running on to open the document has your name configured in user data. That means you have to go to Tools and go down to Options and make sure that user data has your name on it. Okay, so right now, I have the name of my cat, which is Red. I have two. This is the younger brother. So I have Red, as the name of the author. So you got to make sure that when you do your homework assignment, your name is reflected as your user data. And then the next thing you want to do is do not open up multiple documents, like open the same document multiple times, so that you can look at the algorithm and work on the trace at the same time. Instead, use this particular feature. Use Window and then click New Window so that you can now have multiple window or multiple views on the same document. So now I can put one on sheet 1, which is the algorithm itself, and then I can put the other one on sheet 2, which is the trace. So I would just go ahead, do the homework assignment just like this, and then finish it. When I'm all done, I will save the document and then re-upload it back onto the server. I would just double check, before I upload it. I would just double check and make sure that in file properties, I will have my name as the person who created the file, and it will have your name as the person who last modified the file. So those are the things that I'm expecting. Okay. Now, when you're working on the homework assignment, please do not do any type of copy and paste from the outside, because I cannot tell whether it is just copy and paste from somebody else's homework assignment or it's copy and paste from your own document that is somewhere else. Okay, so yes, I am a suspicious person, but now you know I am a suspicious person. Okay? All right, so are there any questions about the procedure about of doing the homework assignment? Yep.
Which one do we save? That one or that one?
Which one?
Do we save?
They are the same document. They are the same
document.
document. They're just two views of the same document. So that means, if you want, you can switch. You can have this one to work on the trace, and this one to work on the to look at the algorithm, because they are really the same document. Let me show you why I say they're the same document. Okay. So let's just say that I'm going to work on this document here. And we will start on line 1 of the algorithm, right? Okay, just watch this. So when I press 1 here and press the Enter key, did you see what happened? It magically appeared on the other side. So that is a good indication that these are actually the same document. They're just on different views. Okay? And that's a really good use of multiple windows, because you can even have one to scroll all the way down here and the other one up all the way up here, and it still works. So that will give you the ability to look at different portions of the same document at the same time, but they're really in the same document. Okay, So what I'll do tonight, or maybe sometime tomorrow, is to go back, look at all the homework assignments where people get no points because of turning in the file that has a problem with one of the steps that I just mentioned. All right? But from now on, you know what I'm expecting, so I will basically enforce those rules from here on. All right, well, since I have the right document open, I'll just go ahead and work on it. Okay, this is the homework that was due, was it last Thursday? Okay, so we'll go ahead and take a look at the solution today, and then I'll show you the new homework assignment, because we have been talking about pre and post conditions for a long time, and I haven't really given you anything to work with, so we'll do that today. All right, line 1, pretty easy. Line 1 is the first line of a pre-checking loop. So what we'll do is we'll go ahead and evaluate the condition and indicate whether it is true or not. In this case, I would say y is less than 3 is true because y has a value of 0 at this point. 0 is less than 3 is true. And because that is true, we have to go into the loop to perform one iteration, and then we have to come back onto line 1 to check again. When we go into the loop, the first thing we do is go on to line 2. Line 2 is just adding the value of k to the variable x. K has a value of 3, and x currently has a value of 1, so that means x will end up with a value of 4 after line 2 executes. Then we move on to line 3. Line 3 is the first part or the beginning of a conditional statement, so we have to evaluate that condition as well. In this case, it is x is greater than or equal to m. M is 5, and x is 4 at this point. 4 is greater than or equal to 5 is false. And where do we go?
1.
We go back to line 1 because the conditional statement is the second condition, the second statement inside the loop, which is also the last statement inside the loop. When you're done with the last statement in the loop, you have to go back to the beginning of the loop, and then you ask that question, should I perform another iteration? Because if the condition is true, then you perform another iteration. I saw a few people doing something like this. Oops, I always hit the wrong key. Okay, I saw a few people did this, copy and paste a portion where it is repeating. That's perfectly fine because I can actually see where it's copying from and where it's copying to. It's from the same document to the same document, no problem. Okay. Someone commented and did not expect me to actually go through the logs and actually see how things are worked on. I actually do just out of curiosity to see how much time it takes for people to work on different things, and where do people usually get stuck with. I mean, that's actually a good indicator of whether people understand the concepts or not. All right, so we are going back to line 1 here. Y it has a value of 0 at this point. 0 is less than 3 is true. So we have to go on to line 2, which is the first line inside of the loop. Line 2 is always going to do the same thing. It's always going to add 3 to the value of x because it's always adding k to x. In this case, it's 4 plus 3, which is 7. And then we move on to line 3. Now this time, line 3 is not going to have this result here because m is 5, x is 7.
Isn't that 8?
Hmm?
Wouldn't that be 8? Because it's k plus x goes into x.
4 plus 3 is 7.
Right, but x is currently 4. So when you add x again, which is 1, and then plus k.
Okay,
4.
which row are you talking about?
On 7.
Row 7?
Yeah.
Okay, on row 7 we are executing line 2. So we have a value of 4 to begin with.
Yeah.
We're adding 3 to it to come to a total of 7.
Plus 1. I mean plus x, which is 1, right?
What?
Isn't
No,
that-
x has changed to 4 already.
It's x plus k.
Damn it. Okay.
Okay. Okay. Now, for those of you who know how to use a spreadsheet, that's an easier way to do it. If you think your arithmetics may be a little bit rusty, like mine, okay, what you do is you just express the whole thing as an equation, So you just refer to the cell that has the old value, and then you say, okay, we'll just go ahead and add the current value of k, and it comes to the right answer as well.
I was saving the previous.
Okay.
And then
So that's why you have to look up the column and make sure that you use the correct value of x, when you're looking back in the trace. Okay, but x is greater than or equal to m is true in this case because x is 7. 7 is greater than or equal to 5 is definitely true. So now we actually have to go to line 4 because the condition is true. We have to go for the then branch. On line 4, we are subtracting m from x. So x will go from 7 to 2 because 7 minus 5 is 2. And then we go to line 5, which is just going to add 1 to y. Y will now end up with a value of 1. And that will end the then branch of the conditional statement. Then the conditional statement is all done, and because it is the last statement in the loop, we are now going back to the beginning, to line 1, to basically ask the question again. Y is less than 3 is still true because it only has a value of 1 at this point. Then we go to line 2. Line 2 is adding 3 to 2 in this case, for a total of 5. And obviously I could have done this also. It's a really good use, it's good practice to use a spreadsheet because that's what a spreadsheet is really good for, is for doing calculations, right?
After 5, if we went to 6 and then went back to 1, would that be all right?
After 5, you go to 6. I think I left comments, regarding that in your homework. So I did not take any points off, for this assignment. But in the future, we do not want to trace the end if, especially end whiles. We don't want to trace those lines. Okay. Because end while is ambiguous. The question is, are we indicating we are getting out of the loop, or are we indicating we are at the end of one iteration and we are ready to go back?
Got it.
Yep. All right, so this is line 2. Line 2 is going to add, so x ends up with a value of 5 after line 2. Now we're on to line 3. Line 3 evaluates whether x is greater than or equal to m, which is 5. And the answer is true because 5 is greater than or equal to 5. So now we go to line 4 again. We subtract 5 from x. X goes from 5 to 0. And then we go to line 5. We add 1 to y. Y goes from 1 to 2. And then we go back to line 1. Line 1 is x is less than 3. This is still true because y now has a value of 2, which is less than 3. Then we go to line 2. Line 2 is evaluating whether x is greater than or equal to m. X has a value of 0 at this point. 0 is greater than or equal to m is false.
Line 2 adds k.
Sorry?
Line 2 adds k plus x.
Oh, okay, 2. That's right. We are not at the conditional statement yet. So we're just adding 3 to x. X goes from 0 to 3. And then we go to line 3. We evaluate the condition. It is still false, but definitely, x now has a different value. And that means we go back to line 1 again because we don't have anything to do, when the condition is false in this case. And then we go to line 2. We're just adding 3 to x again. So x will go to 6. We go to line 3. X is greater than or equal to m is true in this case. We go to line 4. We subtract 1 from x. So x will become 1. Then we go to line 5. We add 1 to y. Y becomes 3. And then we go to where? Now, this is the part that I'm also really kind of curious because quite a few people say that we're going back to line 3. Well, we're not going to go back to line 3 because line 3, 4, and 5, and 6 is not a loop. So it cannot go back to line 3. We have to go back to line 1. Okay, but I'm not quite sure why, quite a few people, mentioned that we're going back to line 3 one last time and then go back to line 1. That's not, what's going to happen here. What will happen is we're going back to line 1, and then we compare y to 3. Y is now 3. 3 is less than 3 is false. And then we get to the post condition, and that's it. A few people also left this line out. So I took 1 point off, because of that. Because it is important to remember when you get out of a loop, you're getting out because the condition of the loop is false. Okay, so that is actually important because that's exactly how a computer would do it too. A computer would actually go back to line 1, figure that the condition is now false, and then it would get out of the loop.
Sorry.
Oh. Okay, are there any questions? For that? Oh, that's new. I didn't know we have a thermostat. Does it work?
Maybe.
You just crank it all the way to code. Is there a cryogenic setting? All right, so that's the solution to the homework assignment. Let me see if I can do this. Okay, just hold on 1 second. I will open up my file server here, open up the browser, go back to the class. What I want to do is I want to see if I can drag and drop the file, so that way you have a link to it from Moodle. Okay, so this is the moment of truth. More nested, drag it over here. No, doesn't do it. Nope. Let's try to save the file. I guess I have to turn on editing first. There we go. So this way you don't have to spend the time to actually copy the file, because the traces will get longer and longer, and I don't want you guys to spend the time in class to do this. Okay, there we go. Nice.
Yeah, I did it like
There we go.
up to I was with you up to line 18 in terms of
You can watch the
how to
video
do-
again.
Yeah, I just calculating wrong.
Okay, well the file is now on Moodle. You can just download it from Moodle. That's the solution, the file that I just saved. All right. Okay, so that part is done, and we'll now take a look at the new homework assignment. The new homework assignment is in topic 4. It is for pre and post conditions. So this is the one that is new, and the instruction is about the same. The entire first sentence is a hyperlink. So you just right-click and save the file. Okay, so right-click, save the file. I'm going to save it to the same folder, which is the 10 folder. Open this in LibreOffice OpenOffice Writer. So this time it's a word processing file. It's not a spreadsheet anymore. There are 2 questions. Each question provides an algorithm, a precondition, and your job is to derive the post condition of the entire algorithm. And there are 2. Points are rewarded based on the demonstration of the understanding of pre and post condition derivation. You must show your steps and reasoning at least to the point that is consistent with how I derive post conditions in class. Okay? All right, so let's take a look at the file that I just downloaded and see what kind of a homework assignment this one is. So we'll just kind of focus on one problem at a time. This is the first problem. The first problem is it has 7 lines, and there's one really suspicious line, line 6. I'll explain that later. It's a conditional statement. Okay, it's if then else. If x is less than y, then we have a whole bunch of assignment statements. Okay, t gets x, x gets y gets t. Kind of strange. And then we have the else, and there's nothing on line 6. And then we have and if. The only reason why I do it this way, instead of this, okay, in other words, I could have done it like this. I just basically tell you this is the same program, okay. But if I give you a conditional statement like this one, most people will miss the else branch. In other words, they will come to the post condition, but only based on the then branch. Okay, in this case, the else branch is very important. Even though it doesn't do anything, it is actually very important. So that's why I give you an else branch that has nothing to do. It's just an empty statement. So can someone tell me, if I can figure out what is pre-6, the precondition of line 6, how do I get to the post condition of line 6?
Post 1 has to be true.
Sorry? Say again?
Post 1 has to be true. Oh, I guess line 6 has to be false.
Come on, this is really hard.
Let's do it.
Because we have never talked about an empty statement, right? Yep, go ahead.
Post.
If the condition isn't true, then line 6 has to be
Yeah, post condition of 1.
No, go ahead.
Since line 6 was everything is pre-6 and post-6 are the same thing.
Exactly. And that's all you have to say. post 6 equals pre 6 because it's an empty statement. It doesn't change any variables. As a result, it doesn't change any of the conditions, and that's why I put this statement here. Okay? But once we have an actual else branch, we can use the same technique that we talked about in class, because the post condition of the entire thing, which is post 7, is going to be just post 4 or post 6. Now you have a post 6 to deal with. If I do not give you an else branch, then most people would miss the else branch, because the else branch has always been there. It's just that sometimes we have something to do, other times we don't have anything to do. Is that okay so far? Does everybody understand what line 6 is and why it's here?
So it's pretty much you're going to just do the same thing except for post.
You just say post 6 equals pre 6 because
Pre-6.
it's an empty statement. It's just like, the statement can be just saying, x gets x, right? Which is basically also an empty statement. In other words, you don't have to use the forget operation or the substitution operation on line 6 because it doesn't do anything. Has no effect whatsoever. All right? So just looking at the code like this, can anyone tell me what would be the result of this code? And by the way, the precondition is not true. Okay, I do tell you something about x and y. I just tell you that x has the same value as n, and y has the same value as m. N and m are not modified whatsoever inside this algorithm itself. So what do you think is the effect of this particular algorithm?
T.
It's actually ordering the variables so that x is always ended up to be greater than or equal to y. That's the effect of the algorithm. Okay? But you have to come to that conclusion based on derivations. So this is one that has no inverse functions, okay? So I'm not going to tell you which rule you have to use for all 3 assignment statements, because I just kind of spelled out half the answer already. Okay, the next one does have an assignment statement that has an inverse, okay? And this one is a little bit tricky too. In terms of the structure, it's kind of like the first one. It's a conditional statement that has an empty else branch. Okay, in other words, when the condition is false, I don't have to do anything. Okay, so I only have to do line 2 when the condition is true, and this also serves a particular function. It serves a useful function. Okay, so I'll leave it to you guys to figure out what function this particular algorithm is going to serve. And it's the same thing. Line 4 is an empty statement, so we can just say post 4 is pre 4 because it's an empty statement. But as a post condition, you have to include the post condition of line 2 as well as the post condition of line 4, which is the same as the precondition of line 4 because it's an empty statement. Okay?
Forever loop? So like a forever loop? Or?
No, it's not a loop. I don't see a while. I don't see a
yeah.
repeat until. It's not a loop. Okay, so remember, it's not a trace. Do not trace this. Okay, do not plug in values. Now, what is even more interesting is the precondition of line 1 is just true. I'm not even going to tell you anything about x in this case. So how can you come to a conclusion that is meaningful when I didn't tell you anything to begin with? Well, it has to do with the structure of the code, right? Are there any questions? Does anyone have an intuitive understanding of the algorithm and kind of know the post condition already? Okay. It's a fairly commonly used math function. Okay. Yep.
X is positive.
Hmm?
X is positive.
Non-negative. There's a slight difference between positive and non-negative. So it's definitely non-negative. Okay, very good. How about line 2? Do you think the right-hand side of line 2 has an inverse function? And I'll leave it to you guys to figure out what the inverse function is. Okay, this one is just a tiny bit tricky, but I think you guys can figure it out. Any other questions? No questions? Okay, so without any questions, what I'll do is I'm going to show you even more examples today. So this way you can know the procedure, how to go from one step to the next step, so that you don't miss any points because you have because you jump several steps. All right, so I will go ahead and close this, and then we'll go ahead and create a new file. I just use mousepad to text my usual text editor and work on some examples. Now the examples that I'm working on is going to be pretty much senseless, okay? It doesn't have any particular meaning. All right. Oh, okay, I think the part of the screen is cut off. Or part of the window is cut off, like that. Okay. All right, let me see if I can answer some questions first. Can I answer a question? I know you guys are talking about class-related stuff, so I want to address it if possible.
Oh, we're just reviewing.
Okay. Alrighty. No questions? Okay. All right. So let's go ahead and follow what we'll be talking about now. Do you have a question?
Can we have the roll sheet, please?
Roll sheet. Yes. Coming right up. What kind of roll do you want? California roll or
Cinnamon roll.
cinnamon roll? No government roll. All right. So let's go ahead and work with this one, and I'll give you, a precondition of some kind. Okay. In this case, I'll give you a precondition of x is greater than 0. Okay, that's all. And there are no particular reason why this is the precondition. It's just I'm just using this as an example. All right. The first thing we want to understand is post 1 doesn't make sense. Okay, we have talked about this a few times, but I will just emphasize and say, no, we do not have a post 1 in this case. Now, line 1 does something, and then we will continue execution of line 1. So how come we don't have a post 1? The problem is, after line 1, we can go to line 2. We can also go to line 4. It's not one single line that is following line 1. There are 2 possibilities. So we can't really just say, oh, post 1 is block. Okay? So instead of saying post 1 is something, we have to say what is pre-2 and what is pre-4. Okay? That is what we want to do, is to say right before we execute line 2, what condition is guaranteed. Right before we execute line 4, what condition is guaranteed. Okay? When you work on pre-2, in this case, you need to clearly indicate that pre-1 is a component. And on top of that, the condition of the conditional statement is the other component. Well, why is that? Is there anything between line 1 and line 2 that might happen and change the value of the variables? No. Nope, absolutely none. So that means whatever is true before line 1 executes must be true also right before line 2 executes. So that's why pre-1 is one of the components. The fact that I'm about to execute line 2 also means the condition of the conditional statement has to be true, so that's why we have x equals k in this case. And then the next line, you can just go ahead and expand what you know about pre-1. In this case, pre-1 is given to us as x is greater than 0 and x equals k. You don't have to say k is greater than 0 because that can be implied by these 2 conditions. You are not adding any additional information by saying k is greater than 0. And we'll just leave this one like this, and then we'll work on pre-4. Pre-4, similarly, is going to be based on pre-1, because if I'm about to execute line 4, I could not have executed anything that can change the value of the variables. And as a result, pre-1 is a component of pre-4. But at the same time, I also know x equals k has to be false, because otherwise I would be executing line 2 instead of line 4. So the precondition of line 4 is pre-1 and not the condition of the conditional statement. And then you can just go ahead and expand this. X is greater than 0 is pre-1, and the other one, it's up to you. Okay, I personally just like to write it as x is different from k instead of it is not the case that x equals to k. But that part is up to you. You guys can change the operator if you want. Are there any questions about pre-2 and pre-4? Yep.
Why didn't you include x is greater than 0 again?
Why?
Uh-huh.
Because it is a different branch. Pre-4 and pre-2 are not related except for one is a then branch and one is a else branch. Okay, if I'm about to execute line 4, right before I execute line 4, would I have any chance to modify the variables since I executed line 1? That's the question. The answer is no. So as a result, whatever pre-1 is still must be true by the time I'm about to execute line 4. Is that okay?
Sure.
Okay. You have to draw the picture. Remember, we drew the picture and we highlighted all the important parts of it. So you want to kind of review that particular picture in the previous class. Okay, so now that we know what is pre-2 and pre-4, we can work on post-2 or post-4. We'll work on post-2 first. Now, when you work on post-2, or when you work on any assignment statements, or the post condition of any assignment statements, you will use this particular format. Okay, it's a very easy format to use. The format is, we say the right-hand side of line 2 is, in this case, f of, now what you put inside the function f is going to be the variable on the left-hand side. In this case, the left-hand side is y, so we'll define the function as a function of y. And then the definition of the function is just whatever the right-hand side is. So in this case, the right-hand side is just y minus 2, so that's how we'll define f of y, is just y minus 2. So this part is just defining the function itself. It's not adding any new information. It's really just a notation in this case. The next line, you have to say, is there an inverse function? In this case,
Yes.
there is an inverse function. Okay, so then you have to say an inverse function f prime of y exists, and f prime of y, which is the inverse function, is y plus 2. Exactly. Okay, very good. Now, because an inverse function does exist, it makes it possible to use which operation?
Substitution.
The substitution operation. Very good. So that's why we're going to say use the substitution operation. Okay. Now, you do not have to be as wordy as I am here, okay? But since you'll be using a word processor as well, you can just copy and paste it, right? Okay. So we'll work on post-2, and this time we are using the substitution operation. A substitution operation has to specify 3 components. The first component is, what are we changing? Okay, the original text. The original text in this case is the precondition of line 2. That's what we are changing. The second one is specifying what are we looking for. We are looking for any occurrence of the variable on the left-hand side of the assignment. In this case, it is variable y. And the last component is saying, what are we replacing y with? Okay, what is the new content or the new value of what we are changing? And in this case, it's f prime, the inverse function, applied to y. Okay, so you have to give me this line. Basically, it's a template. The next line is just expanding what is pre-2 and what is f prime of y. So now you're basically just copying and pasting. So we have pre-2 being defined like this. We have y just being y. And then f prime is this part here. But what I usually do is I put extra parentheses around that particular thing, so that way when I actually do a text substitution, I won't be confused. I won't be confusing myself. Do we have any questions about how we got from line 1 to line 2? It's really just expanding what we already know. It's just basically, one is by definition, and the other one is based on the precondition itself. On line 3, we actually do the substitution. In this case, x is greater than 0. we don't have to do anything about this one because it doesn't mention y at all. And the second one is x equals k, and we also do not have to do a single thing because it does not mention y at all. So in this case, the pre and the post conditions are the same because I did not tell you anything about y. So by subtracting 2 from y, I still end up with no information about y because y is still unknown. It is still undefined. Not undefined, but unknown. We worked on a similar example, I think, last Thursday, where I kind of gave you a precondition that does not involve the variable being modified, and then the substitution operation just ended up doing nothing. Okay. So this is post 2, and then we move on to post 4. Now post 4, you basically work on post 4 exactly the same way. You say the right-hand side of line 4 is f of y also, because this time y is also the one on the left-hand side. In this case, f of y equals to x. Okay. Now, if you want to kind of get reminded why this has no inverse function, there's a new whiteboard marker here. But basically, we're looking at a straight line, a horizontal line, that maps all the values to y to a single value, which in this case is x. So there's no way to reverse it because just knowing that y equals x after the operation doesn't give me any clue of how to reverse the operation back to the original value of y. Okay? So the next line you can say there is no inverse function. Okay? If there are no inverse functions, you use the other operation. There are only 2 operations that we use in this class for assignment statements. So the other operation is called the forget operation. So in the forget operation, the post condition is based on forgetting something in the precondition. And this time you have to specify what you're forgetting, components including which variable? Y, because that's the one that we are changing. And then after this, we also know that y and x will be the same, so you have to add a conjunction and y equals to x after the forget operation, because that part can be confirmed because of the assignment statement itself. The next line, same thing, you just have to tell me what is pre for. So this time pre for is just this part here, and y equals x. And then you just carry out the actual operation. The actual operation is saying, okay, are there any conditions here, any comparison here that include, that mentions y? The answer is no. Okay, y is not mentioned whatsoever here. So in this case, there really is nothing to forget because it doesn't include y at all in the precondition. Are we still doing okay at this point?
So is the actual command irrelevant? Like for post 2, that whole line y is given y minus 2, is that variable irrelevant? What happens to the y plus 2 in post 2? Is it the same case?
It doesn't do a single thing because the precondition of line 2 did not say anything about y. So knowing that, okay, in other words, I'm telling you y has a value, I don't know what it is. Now I'm adding 2 to y. Now I'm asking you what is the current value of y. You cannot say anything because I didn't tell you anything about y before the operation. Now there is 2 more than before. You still don't know anything about y. Okay, so that's basically why the post condition of line 2 is the same as the precondition, because I did not tell you anything about y before, and there's no way I can tell you anything about y now because I didn't know anything about y before. Okay. So now we have post 2 and post 4. Okay, so post 2, post 4 are basically just the way it is described here. Post 5 is post 2 or post 4. And from your perspective, it really is just copy and paste at this point. You just take whatever we have in post 2, put it here, whatever we have in post 4, you paste it here, and you're done. Okay, so it is quite mechanical. Okay, that really is the whole point, is I want this to be as mechanical as possible, so that way, you can apply all of these operations without actually having to think it through and say, okay, but how do I process this one? How do I process this one? You have these rules to help you, determine how to derive the post condition. Okay. Any questions about this particular example? Yep.
Yeah, so why is post 1 does not make sense? Then?
Post 1 doesn't make any sense because when we mention post 1, we are basically saying after line 1 executes, what do we know, right? That's basically what is post 1. But in this case, line 1 itself doesn't do anything to the variables. Instead, it is changing the flow of your program. You can continue execution on line 2. You can continue execution on line 4. That is the effect of line 1. But as a result, we don't know exactly which line is following line 1. Because sometimes it goes to line 2 when the condition is true. Other times it goes to line 4 when the condition is false. That's why post 1 doesn't make sense. It doesn't make sense on 2 counts, basically. Yep, go ahead.
So it doesn't matter how you arrange this because you didn't do like pre-post, as far as that when instructions is.
You mean the order?
Yeah, the order.
The order is not important except you cannot derive post 2 until you have pre 2. You cannot derive post 4 until you have pre 4, and you cannot derive post 5 until you have both post 2 and post 4. So those dependencies are definitely important, but other than those dependencies, you can work on pre 4 and then post 4 and then pre 2 and then post 2. That works out too. So there are no particular order which branch you have to work on first. Yep. Oh, thank you. All right. So do we have any questions about this particular example? Because this one, is kind of iffy because it's just something that I threw out here, as an example. Your homework assignment, on the other hand, is much more meaningful because each one has a particular meaning and it serves a particular function. Yep.
So in post 1, couldn't you possibly put pre 1 also in there as true because nothing has changed?
Pre 1 is true.
Pre 1 is true, exactly. So in post 1, wouldn't pre 1 still be true?
But there's no post 1. That is the thing. I mean, I'm not sure what your
I think he's saying post 1 equals pre 1.
post 1 equals pre 1. But
Because
post 1 means,
Post 1 never, during 1, nothing ever changed. So
Right.
whatever happens, before is still true after.
yeah, but it doesn't help me with the next step.
Okay.
Right, because eventually I want to work on post 5.
Yeah.
And working backwards, I know that post 5 depends on post 2 or post 4.
Mm-hmm.
Post 2 depends on pre 2.
Mm-hmm.
Post 4 depends on pre 4.
Mm-hmm.
And then where do we connect? How do we connect next? They both have to go to line 1,
Yeah.
right? So that's why I use this particular method and just say the pre 2 is pre 1 and the condition of the conditional statement, and I
Okay.
skip post 1 altogether because it doesn't serve me any purpose.
Okay.
Okay. Yep.
So we use inverse only for posts, not pre's, right?
Say again?
We use inverse functions only for posts, not pre's, right?
Right, because the whole idea of using the substitution operation, let me just highlight the portion that we're talking about here. The whole idea of this one is the only part that is not mechanical is to figure out the inverse function of the right-hand side of the assignment. Once you know there's an inverse function, then you know what to do. The post condition is really a syntactical change of the precondition. Okay, and that's why it's useful because it's really obvious for simple stuff like adding 1, subtracting 1, and stuff like that. But if you have something that's a little bit more complicated, this works out too. As long as you can figure out what is the inverse function, this works. So it can help you go from the precondition of an assignment statement to the post condition of the assignment statement, and hopefully you can keep doing this step by step until you get to the end of the entire algorithm. Okay. Any other questions? No other questions? All right. I will not have loops in the homework assignments because loops, as far as pre and post conditions are concerned, loops are particularly tricky. Okay, so we are not going to have loops. Okay. Any other questions about what we are currently doing? Let me ask you this question. Can we have a programming language that has no loops? In other words, no pre-checking loops, no post-checking loops, just conditional statements? The answer is yes, but it also needs something else. It needs to have subroutines. Okay? So there are programming languages out there that has a concept of a subroutine, which we'll talk about in this class, but it has no loops. So what it's doing is using conditional statements and subroutines to emulate the effect of loops. Now, when it's doing something like that, once again, it is actually possible and quite easy in many cases to prove the correctness of the algorithm. But you will have to rely on techniques that we are not going to talk about in this class. One technique is called proof by induction. Does anyone know anything about proof by induction? No? Okay. How many of you are in the computer science track? You're getting a computer science transfer degree. Okay, so you guys will eventually know what is proof by induction, proof by contradiction, two of the most powerful techniques of proving in CISP 440. Professor Fox will make sure you guys get it. Yep, go ahead. One is called proof by induction. The other one is proof by contradiction, which is kind of funny because how do you prove something by contradiction? I'll give you an example later on in this semester. Okay. So are there any other questions about your homework assignment? And once again, your homework assignment is a lot more meaningful than this particular example because both algorithms are actually useful in a larger context. No questions? Okay, if there are no questions, I just want to, okay, let me do this part here. I'm going to save this file, and I'll call this pre-post example 1, and it's a regular text file. Oh, specify. There we go. Save the file, and I'm going to upload the file, so this way you guys can get to it like right now. Topic 4, and the file is pre-post example.txt. Okay. So those of you with a cell phone or a computer that is online right now, you can actually grab the file like right now. Any questions? Questions? Yep, go ahead.
Run another one.
You want another one? Okay,
More
sure.
complex stuff.
More complex. The homework is actually easy. Okay, I tell you, the homework is actually easy.
That's what you say all the time.
Yeah, that's what most people tell me too. It's like, Jack, you said it's easy. Yeah, but it is easy. No, it's not.
Most of us are going to do it on Tuesday, and we're going to get everything over the weekend.
So that's why sometimes when people ask me, is it going to be an easy test? I don't even bother to answer the question. It's like, I think it's easy. Okay, so let's go ahead and work on another example. So we'll go ahead and work with, oh, I don't know, let's see. Okay, we can work with this one. So this is going to say, let's not use x because we have used it so many times. So we'll say if n is greater than or equal to 64, then n gets n minus 64. And on top of that, we'll say b, it's a variable, gets a value of 1. Else b gets a value of 0, and if. And okay, I need to give them my numbers. 1, 2, 3, And this one is also kind of useful too in a larger context. Okay, so we have a little bit of a code here that has a purpose in a larger context, and I give you a precondition as well. Okay, the precondition of line 1 is n is greater than or equal to 0 for sure. And we also know that n is less than 128. Okay. All right. So we have the precondition, we have the algorithm. It's a conditional statement, and it has stuff that is reversible, so we can use the substitution operation. It also has stuff that is not reversible, so we have to use the forget operation. So it has all the things that we need in order to do the homework assignment. So let's go ahead and take a look at this one. Okay. What should I work on next? I only have 2 possibilities at this point.
Post 1? Does nothing?
No, remember, post 1 doesn't make any sense.
Yeah, as I was saying, it doesn't do anything.
Okay, so what do we work with
Pre-2 and
next?
pre-5.
Pre-2 or pre-5. I can work with either one. Okay, just because we read top to bottom, I'll just work with pre-2 first. Okay, pre-2, without even looking anywhere, okay, I can say pre-2 is pre-1 and the condition of the conditional statement, which in this case is n is greater than or equal to 64. Right? Because that's coming from the structure of a conditional statement. It's not even a derivation. It really is just because of the structure of a conditional statement. Okay. What is pre-1? Well, pre-1 is just something that was given to me, and this is what we know about the variables before line 1, and that still has to be true. And on top of that, we also know that n is greater than or equal to 64. And for those of you who want to do simplifications, we can definitely tell that n is greater than or equal to 64 implies n is greater than or equal to 0. In the conjunction, the one that is being implied is useless. Okay, it's not adding anything to the whole expression. So now we can just say, the whole thing is really just saying that n is on one end bound by 128, on the other end is bound by 64.
We don't have to simplify, right?
You don't have to simplify, right? You don't have to simplify for homework assignment purposes, which means I'm not going to take points off if you do not simplify. But the whole idea of understanding that it can be simplified is important in programming. Okay? Because if someone is writing the code using this particular condition, I think it is important for any programmer to understand that it also actually just means that. Okay? You have to be able to establish the second line and the third line are basically saying the same thing. I think that part is important for any developer. Okay? In the context of this class, being able to prove it or not, that's really just algebra, and this is not an algebra class. All right. So the next thing we can do now we have several possibilities opened up. Yep.
So I have a question. Let's assume post condition 6 is actually post condition 1 is true. The condition is true. So for post condition 6, don't we have to write out the precondition for 2 and 3?
Okay. If pre-1 is true, okay, go ahead.
Oh, to find a variable for 3. I mean, I think you were answering it.
It doesn't matter whether pre-1 is true or not because everything is derived.
No, I'm saying if condition is true and it runs 2 and 3, to
Right.
find post 6, don't we have to find the precondition in 3 as well? I mean, post condition.
It's post 3 or post 5. It's the post condition of the last one of each branch, and then you have a disjunction to join those two.
I'll figure it out once you go through it.
Okay, maybe when I go through it, that will answer your question too. Okay, so let's go ahead and figure it out. Okay, so next one, I can actually work on post 2 if I want to. I can finish one branch altogether, but I just think in precondition first. So I'm gonna go for pre-5. Pre-5 has basically the same structure as pre-2. The only part that is different is the condition of the conditional statement is now negated, because otherwise I would not be following the else branch. So the next line is really just expanding what we know about pre-1. And I personally do not like the negation of a comparison result. So I would just change that to become n is less than 64. Does that make any sense? Okay. And that's it. There's nothing else I can do here. Okay. There's no simplification in this case. Yep.
Can you repeat that? Why didn't you put n is less than or greater or equal to 64?
Why is it the negation of n is greater than or equal to 64? Because this condition has to be true when I am about to execute line 5. Well, if I'm about to execute line 5, doesn't it mean the condition has to be false? Because otherwise I would not be following the else branch of a conditional statement.
I missed why you're going to
Hmm?
pre-5.
Say again?
I missed why you went to pre-5 from to pre-2.
Because I want to work on the precondition of both branches first, and then I'll follow through each branch and figure out what they actually do. Okay. I do not have to start with pre-5. I can work with post 2 and then post 3 and then move on to line 5. But this is the way I think. I just think in terms of the structure of the code. Line 2 and line 5 are structurally similar because they're both the first of each branch of a conditional statement. Okay. All right. So now that we have pre-2 and pre-5, I can choose to work on post 2 or post 5. I'll work on post 2 first. Okay. That's really just a personal preference of how I work. So I want to figure out what is post 2, but then I have to look at post 2 and say, oh, okay, it's an assignment statement. Now remember, with an assignment statement, there are two ways to go. Okay, there are two particular operations that are applicable. The first operation that may be applicable is a substitution operation, and the second one is called a forget operation. How do I decide which way to go?
If the right-hand side relates to the left-hand side, then you can use a substitution.
Essentially, is there a way to undo the operation, right? Okay, so the question, that particular question is basically formalized by the following. The right-hand side of line 2 is, in this case, n, f of n is n minus 64. So the question is, does f have an inverse function? Can I reverse this operation? We're just going to add 64, right? Okay, it has an inverse, and the inverse function is f of n is f prime of n is n plus 64. That's why we have to use the substitution operation. Okay. Are there any questions about the rationale of one, finding out whether it has an inverse function, and then decide that we use a substitution operation? Okay, it's not the syntax that is more important, it's really the concept that is more important.
So
Okay.
anytime you have inverse, you have to do the substitution operation.
Because it can preserve more information. You basically keep adding on more information as you go. Okay. Okay, now that we know it's a substitution operation, we first use the template of a substitution operation. We are always working with the precondition. We are starting with the precondition of that line. We are looking for occurrences of the variable on the left-hand side of the assignment operation, and we are replacing each one with f prime applied to n. Okay, that's a template. Okay, we have seen this before, haven't we? Okay, the only part that changes would be the line number, which variable we are looking for, and what we are replacing it with. But the template is the same. Yep.
For let's say for like variable b, right? For post 3, it would have to be like a pre-3 where b already has like an unidentified number associated with it, right? Or to have 1 afterwards in the post condition.
An unidentified function object, and UFO. Okay, I see. I guess half the class is still awake. That's good. Well, when we get to line 3, you'll see. Okay, we don't have to start with anything because it's an assignment statement with a irreversible operation. So I don't have to start with anything, and I can still end up knowing something. It's because it's an assignment statement. So we'll get to that part. Okay. All right. So now that we know this is the template, the next thing we do is we're just going to expand what is pre-2 and what is f prime. Okay. Pre-2 is something that we figure out a little bit earlier, so we just copy and paste it here. F prime of n is also something that we just figure out, so we'll put it here. And as usual, I put parentheses around it, so that way if someone is actually doing a text operation to replace everything, that will still work. Okay, now we do the actual substitution. Okay, I cannot remember whether this editor has the feature to do this, so I'll go ahead and see if I can do that. So I'm going to select the text that I'm supposed to perform the search and replace operation, and we'll go find and replace. I can actually do that. Okay, so we're going to search for all occurrences of n, and then we'll replace every single one with n plus 64. Search direction is down. Replace all in selection. Oh, okay, I lost my selection. Come on. There we go. Does it work? Okay, let's try it again. Trying to be lazy, and obviously that's not working to my favor. See, as soon as I type n, it doesn't work. Can find all in the document, but that's not what I want to do. I just want to search and replace.
Selection, and then while you have that window open, highlight it, and then press OK.
Okay. Say again?
So
search for n.
Search for n, replace with n plus 64. Search direction is down.
Replace with.
Replace with.
Selection.
Then highlight right now.
Before you, there you go, select. And click replace all.
Spaces around the end.
Oh, okay. But it doesn't tell me there are how many occurrences. I was hoping that it would do that. Oh, it's replacing the
end.
Great. Now there is a way to do this.
If you just did a left paren.
words. Okay, there we go. Okay, I think I can fix that. Okay. I end up wasting a lot more time doing this shortcut than just doing it by
search
text.
for left paren, then.
No, we can. This is how we're gonna do it. We will do a match whole word. That's what is missing the first time. Okay. So. Selection. No, it doesn't work. Oh, I think I missed that. Okay, one more time. Oh. Redo. No. All right. Okay. I think this is easier. Fine. Okay. Wow. If I were using VI, this would not have happened. Okay. VI is a text editor that is considered the one of the most popular editors for developers, 40 or older. If you ask anyone younger than 40 and say, do you use VI? And they're like, VI? You mean that really archaic editor that my professor, forced me to use in college? Yeah, but it's actually pretty useful. Some of you will end up using it. Okay, so that's basically the end result. Okay, I apologize for all the distraction. Okay, some of you will look at this and go like, well, that looks really, really ugly. I want to simplify this. Okay, and it can be simplified very, very easily because you just have to subtract 64 from both sides of the comparison, and it will clean it right up. So we'll just go ahead and clean it up. N plus 64 becomes just n. 128 becomes 64. On the other side, it's just n, and then the other side is greater than or equal to 0. That looks suspiciously similar to something that I used to know. Right? Okay. All right. Knowing that, let's move on to the precondition of line 3. The precondition of line 3 is just the postcondition of line 2 because lines 2 and 3 are sequential. Okay? In this case, there's no mystery why line 3 is following line 2. Now we want to derive what is post 3. Okay, same questions. So we want to look at the right-hand side of the line that we are working with. In this case, it is line 3. And we'll define that to be f of b in this case. And it's just 1, okay? Because that's the right-hand side. Does that have an inverse function? In other words, if I plot b versus f of b in a graph, it is a horizontal line at 1, right? So it maps all the values to a single value of 1. Is that reversible?
No.
No, absolutely not. Okay, so I can say now there is no inverse function, and as a result of that, we have no choice but to use the forget operation. Okay, which is not preferred, but in this case, that's the only thing we can do. But in this particular case, we actually end up gaining something by using the forget operation. Okay, so we'll see how we are doing that. Post 3 is the result of a forget operation, and we are going to forget something potentially in pre-3. What we're going to forget is everything that mentions b, because b is the one getting changed, and I can no longer guarantee the same conditions will hold true whenever it involves variable b. But I got one thing going and saying, oh, by the way, after this particular assignment statement, now we actually know something about b, don't we? What do we know about b? B has a value of 1. Very good. Okay. So now let's go ahead and actually perform the forget operation, which is really just copying and pasting post 2, which is over here, and then b over here, and then we now actually go ahead and perform the forget operation. If you just look at the highlighted portion here, does that mention anything about b? Nope. So if I were to tell you, forget everything that we knew about b, and that's all that you knew, are you going to forget anything? No, you're not going to lose anything. All right, so that's good. We just do a copy and paste here. Oops, copy, paste. But don't forget the last one, okay? Because this conjunction and b equals 1, these are outside of the forget operation. So we are actually knowing something more than what we knew before. So did I answer your question?
That's the exact answer I was asking, because
okay.
I assumed you weren't going to even look at the line 3.
No, we're going to go through every single line and go through the derivation just like what we are doing.
So what if you gave precondition 1, you gave b a value in precondition 1.
Okay.
And you changed its function on line 3 to like x.
Then you will forget what you knew about b, and then you add that b is now 1. Because the forget operation will basically erase everything that you knew about b, or how b relates to constants and variables before this particular line. Okay. All right, so that's good. That's good to know. Okay, now that we're done with line 3, let's go back and work on line 5. And what I'll do is I'm going to just copy and paste that line because it's scrolling out of the screen, and post pre-5 is over here. So I'm just going to copy and paste this stuff here, just so that we can look at it more easily. All right, so now we have line 5 and we have the precondition of line 5. So we're going to use exactly the same procedure to determine what to do with line 5. Is it starting to get kind of boring and dry and mechanical? If so, good. If not, we're in trouble. Okay? Because that's the whole point of these particular rules. It's so that it's easy for you guys to look at the statement that you're dealing with and know what to do with it in order to derive the post conditions. Okay? So it is good that you're feeling, oh, this is boring, this is mechanical, this is repetitive. That's exactly what it is supposed to be. Okay. So now we worked with this one. We first asked the question. The right-hand side of line 5 is f of b is 0. Okay, so it really is kind of the same thing as before, right? I mean, there are no inverse functions, and we're going to say that we'll use the forget operation. So just like before, we're going to say post 5 in this case is based on pre-5. We'll forget everything that we knew about b, but on top of that, now we know b has a value of 0 because that's what the assignment statement is going to do. And then we'll go ahead and expand what is pre-5. Pre-5 is this part here. And we'll forget everything about b in that conjunction. And then we'll say, on top of that, we also know that b equals to 0. And once again, what we knew before did not include anything about b, so there's really practically nothing to forget. We get to keep the entire precondition. And on top of that, we also know that b equals to 0. Are we working okay so far? Okay. Now what do? We have, if you look at the original code here, we have the post condition of the last line of the then branch, and then we have the post condition of the last line of the else branch. Now we're ready to work on the post condition of the entire thing, which is post 6. So now we have post 6 here. Post 6 is, because of the structure of a conditional statement, it is post 3 or post 5. Okay, so that part you just have to write it here because it is the merge point of the two branches of a conditional statement. And then the next one is really easy. It's just really copy and paste, post 3, which is this thing here, and also post 5, which is this part over here, and we're done. Now, if you look at the post condition, don't you think it has some kind of symmetry going on? I see a little bit of symmetry because certain parts of the conjunctions are common. N is less than 64 and greater than or equal to 0 is actually common to both sides of the disjunction. So no matter which branch you take, N is guaranteed to be bound by 0 on one side and 64 on the other side. Now, B, on the other hand, can be a 1 or a 0. Can anyone tell what, this is an algorithm in a larger context, but what do you think that context is for? There's a particular reason I chose the word B in this case. It's a bit, okay? It's a binary digit. This is actually one step of converting a number into a binary representation. Remember we talked about binary representation in this class, how I said, it's actually easier than coming up with change, okay? This is actually one of the steps. This is determining whether we have 1 or 0 $64 bills. But the precondition is the amount that we are dealing with is 1, non-negative, and 2, it is less than 128, because we would have taken care of the 128 with a single $128 bill already. Okay?
Can you simplify that last line at all, since you do have common values in it?
Yeah, we can. So this is definitely an optional step here. So for those of you who really do not like, seeing the same thing on both sides, if we can simplify it, why not? Okay, so the simplification is like this. Okay, so we have n is less than 6. Okay, I typically want to say greater than or equal to 0 first, and then n is less than 64. And then what we do is we'll say the whole thing and b equals 1 or b equals 0. It's the reverse of applying the distributive rule in algebra. So you're basically saying AB plus AC. We start with AB plus AC, and then you just say that it's A times open paren B plus C. So we're reversing the application of the distributive rule of algebra.
Boolean stuff.
Yeah, it works the same way in Boolean algebra.
Okay.
Yep. So that's a little bit easier to read because now we know that n has to be from 0 to 64, but b can be 0 or 1. It cannot be anything else.
Yeah.
Okay, so b is guaranteed to be either a 1 or 0. Now, in this case, I can say it's either because it cannot be both at the same time. All right. Are there any questions about this particular example?
So just in terms of the forget operation, it's pretty much the same thing as the substitute, except that you're inserting.
It's fundamentally different because with the forget operation, we are trying to lose information in the precondition about the variable that we are changing. So we are not maintaining, a relationship by reversing the operation, which is what the substitution rule is about. Okay. All right. So for those of you who are also kind of curious of, okay, if this is really a part of a larger algorithm, what would be the next step? What do you think? Okay, I'll just give you a little preview here.
Greater than or equal to 128.
You got the right idea, but the wrong direction.
Yeah, good.
The next step would be a $32 bill, and obviously I should not use B again because it would just erase what I had before. But that's basically the next step. And then after that would be 16, 8, 4,
Okay, just go the
2,
other way.
and 1 is trivial. Right. Yep. Okay. Are there any other questions? Yep.
In what cases pre and post are the same? For example, see, post 2 and pre 3 is the same thing, right?
Post 2
Because they're the
and
same.
pre 3 are the same because the 2 lines are sequential.
Yeah,
Because-
so if they're sequential, it's supposed to be the same. Doesn't matter, right?
Right, because because when you get out of one statement, you're about to execute the next statement. So that's why the post condition of 1 is the same as the precondition of the next. Any other questions?
And we wouldn't need to expand post 2 in pre-3, just because
Nah,
it's right there.
yeah, it's really,
Okay.
because otherwise you'll
It's
just
just
copy.
mechanical.
Yeah, it's just, that part is completely, it doesn't have to be mentioned. Okay. Are there any questions? Now, if I really want to summarize all of this stuff here in kind of more or less, abstract stuff, I'm not sure, about this step because some people feel more comfortable when it's expressed in a more abstract way. They say, oh, this is a template. I now understand what we're talking about. Other people look at more abstract description and go, I'm not quite sure, okay, because I don't know what C stands for, what S1 stands for, and what S2 stands for. So, but I'll give it a try anyway, okay? So in this case, I'll just say we're dealing with line N. I'll choose an uppercase N here. This is the line number, and it's an assignment statement, okay? The assignment statement is we have a variable on the left-hand side, and it is the right-hand side is simply expressed as a function of v. Okay, so in this case, there are 2 rules to express, okay? So we basically say if f prime of v or the inverse function exists, then we do one thing, otherwise we do some other thing. So this looks like a conditional statement all by itself because it is describing what we are going to do when we encounter a assignment statement in general. Okay, if an inverse function exists, we basically use the substitution operation, and then we say the post condition of line N is based on the substitution operation applied to the precondition of line N, replacing all occurrences of V with f prime applied to V. Okay, the rest I cannot show because it depends on the actual precondition and the actual inverse function. The else case is basically saying, what if an inverse function does not exist? Well, we use the forget operation. The forget operation says the post condition of line N is based on the forget operation applied to the precondition of line N, and we are forgetting everything that we knew about the variable that we changed. In this case, it is V. But on top of that, we can also say, from here on, we know for sure that V is the same as f of V, which is the right-hand side of the assignment statement. Okay, so some people look at this and say, oh, so that's what you were talking about the entire time for the past 3 classes. Why didn't you start with this, right? Some people look at this and go, well, I really don't want to deal with this. I'd like the other examples better. Okay, so it depends on your learning style, how you work on logic and stuff like that. I'm not saying one way is better than the other way. We all learn differently. Okay, and there's one more that I can throw at this one here. So we have line N plus 0 is if, and in this case I just use condition C. So I'm not even telling you what C is. Okay, and then we have N plus 1 is the beginning of statement 1. Okay, we'll just call this statement 1. And then we have N. Okay, we'll call this N plus K. Okay, that's basically the last statement here. Statement K. Okay, fine. And then we have N plus K plus 1, which is our else. That's just a keyword to separate the then branch from the else branch here. So once again, I'm trying to use a very generic description of a conditional statement, and then you can use a template to figure out how to derive the pre and post conditions. Then we have N plus K plus 2 is statement, I would call this K plus 2 just so that it's easy to deal with. And then we have Kn plus K plus N. Okay, that's the last one. Statement K plus N. Okay. and then we have n plus k plus n plus 1. That's really just for counting the number of lines, right? I mean, this. Okay. So now we have a really, really general description of any conditional statement. Okay. If you don't have an else, that means statement k plus 2 to statement k plus n are empty statements. Okay. All right. So the general rule is basically saying the precondition of n plus 1, line n plus 1, is the precondition of line n, which is n plus 0, and the condition c. The precondition of, in this case, n plus k plus 2 is also the precondition of line n, because whatever was true back then still has to be true at that point, and not c, the negation of c, because otherwise I would not be following the else branch. I cannot tell you how to go from n plus 1 to n plus k, because that really depends on what kind of statement I have in those particular branches. But one thing I can tell you for sure is the post condition of n plus k plus n plus 1 is the post condition of n plus k, or the post condition of n plus k plus n. That is the general template of any conditional statement. I'm not sure. I mean, some people are nodding and some people are going like, oh, I'm running low on sugar. Let me go. I need to go home. So, I'm not sure whether it's going to be helpful. I'm just going to throw it out there anyway. If you feel this format is helpful to you, good. If you don't feel it's helpful to you, keep it in your notes anyway, just in case in the future.
You can upload it?
Upload.
I can certainly do that. Sweet. And I'll save this one as super notes on C proposed conditions. Were you talking about the zero?
Taking that long, right?
Positive and non-negative.
Oh, no.
Right. Zero is
Yeah,
non-negative,
exactly,
it's not
yeah.
considered positive.
When I go to that song class, I find all your tapes, and they're always like old tapes, like I can't.
Yeah, the some crop stuff is. What do you mean by old? You mean the
They're
video
ones
stuff?
that are like 3 years old or
Oh
something.
no. We got new stuff.